difference and symmetric difference of sets. Now, when you are asked to find the difference between any two given sets, basically you are looking at what is present in a particular set but is not found in another set. Unlike the complement of set where we make reference to the universal set, when dealing with difference of sets or the symmetric difference of sets, the concern is between those two sets. For instance, the difference between set A and set B is written as A minus B. Then the difference between B and A is B minus A. So the difference between A and B, simply, you are dealing with elements that are found in set A but are not found in set B. While the difference between B and A is elements that are found in set B but are not found in set A. So from this question, we are asked to find the difference between A and B if set A is equal to 1, 2, 3, 4 and set B is equal to 3, 4, 5, 6. The difference between A and B, which is represented by A minus B, will be the elements that are found in set A but are not found in set B. And those elements include 1 and 2. 3 is found in set B, 4 is also found in set B. So the difference between set A and set B is that you have element 1 and 2. So that is A minus B, the difference between set A and B. And the correct option here is A. In case you are asked to find the difference between set B and A, that is now going to be B minus A. And that will be the elements that are found in set B but are not found in set A. So when you look at the elements in set B, you have 3, 4, 5, 6. 3 and 4 are found in set A. So the only elements that are found in set B but are not in set A includes 5 and 6. So B minus A will be equal to 5 and 6. So that is how to find difference of sets. Difference of sets, you are basically considering those two given sets per time. Now let's look at a question from the symmetric difference of sets. For symmetric difference of sets, let A and B be any two sets. The symmetric difference of A and B is the union of A minus B with B minus A. That is, we just finished looking at the difference between two sets above, where the difference between A and B is represented by A minus B, while the difference between B and A is represented by B minus A. So symmetric difference between two sets A and B is represented by this. This is showing the symmetric difference of A and B. And this is equal to the union of A minus B with the difference of B minus A. So anytime you are asked to find the symmetric difference of two given sets, what you should be looking out for is the union that exists between the difference between the first and the second set, thereafter the second and the first set. So in this case, we have set A equal to 1, 2, 3, 4. Set B, we have 3, 4, 5, 6. So the difference between A and B is what is present in set A but is not present in set B here. We have 1 and 2 union B minus A, elements that are present in B but are not found in set A. And for that we have 5 and 6. So that the symmetric difference of A and B now will be equal to, we are now finding the union between A minus B with B minus A. And the union here we have 1, 2, 5, and 6. So this is the symmetric difference of A with B. Looking at the options here, the correct option is none of the above. Because when you look at A here, A is the difference between A and B. When you look at option B, that is the intersection between these two sets. Because set A has 3 and 4, set B has 3 and 4. So that is not the correct option for this question. When you look at option C, 5 and 6 here, 5 and 6 is B minus A. That is the difference between set B and A. Elements found in set B but not in set A. So the correct option here is none of the above, because the symmetric difference of A with B is supposed to give us 1, 2, 5, and 6. So basically, it suffices to note that the symmetric difference of A with B does not include this A intersection B. A intersection B, basically, you are referring to those elements that are common between both sets. When you look at set A and set B here, elements that are common are 3 and 4. So when you look at the symmetric difference of A with B that we have found here, you discover that there is no 3 and 4. So symmetric difference does not include the intersection between the two sets.